Once again we are going to perform some more practicals of MPLS. MPLS is running already here on 2R1, R2, R3. SPF is configured, right? But BCP is still not configured over there, right? And today I'll be configuring this VPN for address family, BGP, in different manner. Today I'll do this configuration in that manner so that I'll require to have route reflector, because you see that in a network, in an enterprise network, let's say this is P router, this is P router, this is P router, and this is another P. All P's will be connected, right? Provided edge routers, they are connected in this manner. Now let's say there is a customer connected behind this PE1. There is another customer which is connected with PE3. Another customer is connected behind this PE3, and this customer is connected behind PE1. Now PE1 does not have direct connectivity, direct neighborship with PE3. Are you getting my point? So how would it be possible for BGP to take your prefixes from this PE1 to PE3? In that case, you can use here, there will be two options: either create VRF over here as well, or make it what? So even in VPN v4 also we can configure route reflectors. So today I will implement this VPN v4 in such manner so that I will require to configure route reflectors, right? So I will not configure direct neighborship in between R1 and R3. I will configure neighborship, VPN v4 neighborship in between PE1 and P router, and then further in between P router and this another PE router. Let me do that first. So on to R1, say router BGP 100, no BGP default IPv4, unicast neighbor 2.2.2, remote AS is 100 2.2.2, update source is loopback, address family, neighbor, say activate. Move on R2, router BGP 100, no BGP, default IPv4, unicast, neighbor 1.1.1, remote AS is what? 100, neighbor 1.1.1, update source is loopback 1, neighbor 3.3.3, update source is, sorry, first of all, remote AS is 100, the neighbor 3.3.3, update source is loopback 1, address family VPN v4, neighbor 1.1.1 is what? Activate. Neighbor 333 is what? Activate. Then on R3, router BGP 100, no BGP, default IPv4, unicast, right? Neighbor 2.2.2, remote AS is 100, neighbor 2.2.2, update, sorry, we are doing correctly, right? We are doing correct configuration, right? I thought that I have done some mistakes over here. So it will be same, loopback 1, then address family VPN v4, then say neighbor 2.2.2 is what? So is there any problem in it? Now neighborship must come up, right? In between R1 and R2, and in between R2 and R3 as well. So we can check it out onto R2 itself. Like with R1 it has formed VPN v4 neighborship, but still it have not came up with R3. It have came up now, right? To check it out, say show IPBGP VPN v4 all summary. Fine guys. After it, now VPN configuration is done over MPLS, right? Over service provider network. Now there is a customer, and see, for both customers I'll be using same prefixes, right? Are you getting my point or not? Here for both customers there is one customer Microsoft, another customer is what? Yahoo. For both customers I will be using same prefixes, right? Yesterday we saw that how to configure RIP and all, right? Yesterday we saw that how to configure RIP and all these things, right? Today I'll do configuration of BGP in between PE and CE. So today I'll let you know that how to configure BGP in between PE and customer edge, PE and CE, right? So here in place of RIP I'll be configuring BGP, and at the end of customer I'll be using AS 65500. Understand? I'll be using BGP AS 65500, and in same manner in place of this EIGRP, should I use EIGRP or not? Okay, in place of EIGRP let's configure same AS, because it's the same user, same customer, right? So let's say it's using same AS 65500 over here as well. So this customer Microsoft is using common AS, same AS on both, I mean in both locations. Fine. Then after it here OSPF area 100, that's fine. In place of it let's make it what? EIGRP 100. Here it is OSPF. So today I will also teach you that how to configure OSPF in between PE and C router. First of all I will start from BGP. I will do configuration only for Microsoft. First of all we will do configuration for Microsoft, and then after I will do configuration for customer Yahoo. Have you gone through previous videos or? So now I'm on R1. The very first thing that will be required over here is we have to create its VRF. So IP VRF name is, let's say for Microsoft I'm using micro. I have to allocate RD value, let's say it is 1:1. Then after it I have to allocate route target. Let's say for exporting I'm using 1:2. For importing I'm using 2:1. So make sure that over there on another end for export I'll be using 2:1, right? Then just come outside, go to FA0x0 of this device and provide membership of VRF. Tell me micro, and then allocate its IP address is what? 1.2. Today I'll allocate its IP address on /30, not on 24, because only 2 IP addresses are needed over there, right, in between P and C. So no shutdown, so it will come up and you see issue IP route VRF micro, only this directly connected prefixes will be there, right? Then move on, Microsoft CE1 on its FA0x0 I have to allocate its IP address as 1.1. No, there is no need to configure VRF. Will you configure VRF at the end of customer? Then 10.1.1. Loop back to 3, 4, 5. Understood? Router BGP is what? Right? Neighbor. Oh, I think do show run interface FA0x0. Let me show you. Okay, we configured correct correct subnet mask over here. So say neighbor 192.168.1.2. Remote AS is what? Fine, redistribute. Now we have to do configuration at the end of PE. Let's move on PE1. This is your PE1. Now here on PE1, where will you configure neighbor command? Where are you having this neighbor? This neighbor is existing in VRF micro. This neighbor is existing in VRF micro. So you do one thing, say router BGP 100, address family IP v4 VRF, name is what? and then say neighbor 192.168.1.1, remote AS is 65500. That's fine. Fine. And see here, you will not require to perform redistribution, same unlike previous class. Like in previous class we performed too much redistribution from REP to BGP, then vice versa, and then EICRP to BGP, and then BGP to EICRP. Today we will not require to perform redistribution, but where you are using only and only BGP, because prefixes can move from BGP to BGP without now. You can ask me, sir, why is how will it be possible to put from BGP table into VPN v4 or something like that? See, if you are creating address family for VRF, it is itself kind of VPN. It is itself what? VPN, because one VRF represents one VPN, right? So this time, see, if you say show IP route, there is nothing like that. There is nothing. If you say show IP BGP in global BGP table, there would not be anything. But if you say show IP BGP VPN v4 VRF micro, enter, all these prefixes are there because it have received via BGP. In VRF micro, show IP route VRF micro. Fine. So all these prefixes are available over here. Then after it, show MPLS forwarding table. See, BGP VPN v4 label have been originated it even without redistribution, because it is not required over here, because we are talking or we are configuring BGP here. So now I must be able to get them onto R3, but on R3 I will not get them because I have not created any VRF. So onto R3 I have to create now VRF. So let's do one thing. Say IP VRF is what? Micro. Even you can take different VRF name as well, doesn't matter. RD should be same. Route target for import, it should be 1:2, and route target for exporting I'll be using. Do you remember? Hello. In previous class I explained it in very depth actually, that what is the uses of this route target and all. Now I must be able to receive prefixes over here onto R3, right? Show all, enter. Does it have anything over here? The thing is, like, R1 is having neighborship with R2 and then R2 is having with R3. So R2 is not gonna to advertise them towards R3 unless you configure it as a route reflector. So move on R2 now, and you can also see here show IP BGP VPN v4 all, enter. Is it showing you anything? Now do one thing, make it route reflector. Router BGP is what? 100. Address family VPN v4, enter. Neighbor, and now check show IP BGP VPN v4 all, enter. See, Even R2 is also having now all these prefixes in its VPN v4 table, but in global routing table it does not have anything. See, on to R2 as well. Does it have? So MPLS forwarding table, does it have anything in its forwarding table now? No, but in VPN v4 table it is having all those prefixes, right? And now you must be able to see them onto R3 as well. So IP BGP VPN v4 all. Check it out. And then you must be able to see all of them inside routing table of VRF micro. So IP route VRF micro. See, and then again configure BGP in between Microsoft site Gurgaon and PE2. So this R3 is working as a PE2. You must remember that it is working as a PE2, and whereas this R1 is working as a PE1. So interface FA0/0 of R3 will be in VRF micro. So IP VRF forwarding micro. Now shut down. IP address is going to be now 2.2 on /30 itself. So IP route VRF micro. Fine. Move on. Microsoft CE2. Create some loopbacks. Router BGP, here also I will be using same as neighbor. Tell me 2 dot and then say redistribute. On P3 once again router BGP 100 address family IPv4 VRF name is micro, and then you can say neighbor is 2.1. remote AS is what 655 double. Neighborship must come up. Even on PE2 also you will not require to perform redistribution because prefixes are going from BGP to BGP. Move on Microsoft CE2, you must be able to see all of those prefixes in neighborship have came up now. So IP BGP. It does not have anything. There is no 1, 2, 3, 4, 5, nothing like that. Why does it not have all those prefixes? Due to same AS. Because they are coming with same AS path attribute, right? So if you say debug IPBGP update and then say clear IPBGP star in, check it out. It will show you that it is denying those update due to AS path contains on AS. So do one thing now. Router BGP 655.0 neighbor 192.168.2.2 say allow AS in. Once you will configure this command, now it will start to receive all those prefixes which are containing same AS path. Show IPBGP, you see. Just wait. You have to do wait because the minimum time interval in between two advertisement for eBGP neighbor is 30 seconds. You see. So it is showing us that okay, they are coming after crossing 655 double. I mean they were originated from 655.0, right? Hello. Have you understood it or not? So here you can see that in a path list 655.0 is existing, whereas on this router also we are using the same AS, but still we have allowed all those prefixes which were containing are on AS. Right? Now you can find all those prefixes available in your routing table. See 1, 2, 3, 4, 5 via BGP. Is there any problem? Fine. Router BGP is 655.0. If you remove this command from here, allow AS in once again you will see that all of them will be removed from its BGP table as well as routing table. Check it out. Gone. Swipe it out. Nothing. So if you do not want to allow, if we do not want to configure any command at the end of customer, then service provider itself can configure this command at its own end. Like P, this is what? P router BGP 100 address family IPv4 VRF name was micro and it was neighbor 2.1. We could also say here in place of AS path, allowed AS path, that AS override. For this command, ISPs can configure AS override command. The uses of this command is same as like AS path, allow AS in, but its output will be bit different. Like if you move on Microsoft CE2 now, you check it out, show IP BGP, it is showing me that it is coming after crossing AS 100 only, and there are 2 times entries available of AS 100 under AS path list. So in place of 65500, that PE router have placed AS 100. So PE router 2, hey, PE2 have override AS 65500 with AS 100 itself. So that is why when this Microsoft CE2 received all these prefixes, it didn't found AS 65500. That's why it accepted all these incoming prefixes this time. So this is the uses of AS override command. So I hope that you people have understood the uses of allow AS in as well as AS override command. Is there any problem now? Tell me. After it, in same manner, prefixes will go from here to there. But you can see that Microsoft CE1 is still not receiving all those prefixes. Reason? Because they are coming with same. Yes, you can say debug on CE1 as well. Like debug IPBGP update and then say clear IPBGP start in. Say denied due to AS path contain are on AS. So here also you can use either allow AS in command or AS override. Remember that AS override will always be configured at the end of provider edge. Neighbor 1.1 and say AS override. Once you will configure this AS override command, move on PCE1, Microsoft CE1, check show IP BCP table. See, it have received all those prefixes, right? Hello. And once again, you can try to communicate with the 10.1.6.1 when source is loopback. One repeat is whatever you want, so there will not be any problem. And still, your core router do not have these prefixes available in its routing table. Right? So today we have also configured this BGP in between PE and CE as well. What? R2 doesn't have any route in its routing table. Those prefixes are available in its VPN-v4 table only. And we do not have that VRF over here that contain that RT values. That is why here you cannot find those prefixes in its routing table anywhere. Because it does not have any VRF over here.
So if you show IP VPN-v4?
Yes, show IP BGP VPN-v4 all. Enter. Then it can show you all those prefixes. And see, next hop has been modified automatically. And in previous class I have already explained you all these things. Fine. Now let's do some configuration for customer. Yahoo. Start from PE1 itself. FA, first of all create one VRF. VRF name is RD is what? Route target. For exporting I'll be using 3:4. Route target for importing, let's say, tell me. Okay, this time I'll not configure anything for importing. Let's say I'll do this configuration later on, right? So I have configured only for export here, right? I have configured this route target value only for exporting your prefixes from VRF into VPN, right? So now do one thing, move on FA0/1, say IP VRF, forwarding name is Yahoo, IP address is 192.168.3.2. Right, then after do one thing, move on Yahoo CE1. I mean, let's have the console of Yahoo CE1 now. And this is Yahoo CE1. On its FA0/0 I'm going to configure 3.1, and over there I use /24 or /30.
24.
Sure, because in OSPF subnet mask must match. Create loopbacks 10.1. Sorry. Three. So router OSPF 100. Router ID is 100.100.1. Anything. Then network. Area. Show IP OSPF interface. Brief. Loopbacks will be advertised on /32. To solve that problem, what can we do? Now we have to do configuration at PE1 for VRF Yahoo. We have to configure OSPF now for VRF Yahoo because customer is using OSPF, right? So I'll be saying router OSPF, it was 100. Here in OSPF version 2 there is no address family, right, for VRF. So here you have to call your VRF over here. VRF name is what? Yahoo. So this process ID of OSPF will be associated with this VRF Yahoo. That is why here in OSPF we are using this process ID. So now if someone asks you that what is the use of process IDs in OSPF, so you will simply tell them that basically these process IDs were used to associate them with VRF, because in OSPF it is not possible to create address families for VRF. In OSPF version 2 it is not possible to create address families for VRF, so over there we were configuring these process IDs, right? And then allocate router ID like 100.100.100.10. Any problem? It's different from there. Then you have to enable network 192.168.3.2 and area is going to be 1. Now your neighborship must come up. However, it will take some time. So what can we do? We can move on FA0/1 IP OSPF, or let it be. Now neighborship have came up because DR was already elected. Otherwise, what can you do over here? You can configure its network type as point to point itself in between PE1 and Yahoo customer edge 1. Like in this way, FA0/1 IP OSPF network type is what? Point to point. In same manner, you can move on Yahoo CE1 and on its FA 0/0 IP SPF network type is what? And now this PE1 must be able to receive all prefixes coming from Yahoo. Are you getting my point or not? Hello? This PE1 must be able to receive all routes coming from customer Yahoo in VRF Yahoo itself. So say show IP route VRF. And same prefixes are also available in micro. They are coming with the help of BGP. You understand? But this time we are using different VRF, different RD values are there, right? Now, as you know, by default prefixes can't move from OSPF into BGP. Is it possible? So this time you will have to perform redistribution. So for doing that, say router BGP 100 create address family for VRF. Tell me. Yahoo. And then say redistribute what? OSPF 100 VRF name was also. Because here we are using VRF along with this process ID, right? And then after redistribution, now you must be able to see all of them in its VPN v4 table, right? Check it out. Show IP BGP VPN v4 VRF is what? Micro. First of all, check BGP table for VRF micro. See, all these prefixes are there coming from 1.1. You understand? And then say for VRF, tell me Yahoo. All these prefixes are same. See, and they are coming from 3.1. Have you understood it or not? Same prefixes are coming from 1.1 and same prefixes are coming from 3.1, but their RD values are different. You see, route distinguisher. Here it was 1:1 in VRF micro. In VRF Yahoo it is 2:2. This is RD route distinguisher. And then after, check its MPLS table as well. Show MPLS forwarding table. As I said that whenever you will inject your prefixes from VRF into VPN, it will generate a label. You see, for same prefixes, this is same prefix, see 10.1.0. For it generated VPN v4 label as 24. See, local label is what? 24. And outgoing interface is FA0/0, next hop is 1.1. But for same prefix, you see over here that you injected now you injected it, right? But RD was different. That is why VPN v4 created a different tag for it, because RD was different. That is why VPN v4 created a different label for the same prefix. But this time, see, exit interface is what? FA0/1, and next hop is what? 3.1. And now it will provide the same information to its neighbor. Because it will advertise this label within BGP updates, as we proved it in previous class. Hello, it will send this label information in its BGP updates. So now let's move on R3 and create one VRF. Name is RD, should be same. Route target for exporting, it must be for import, because right now we are importing them, right? So 3:4. That's the only thing that we are required to do right now, right? And then after, I must be able to see all of them in VRF Yahoo. So let's say show IP BGP VPN v4 VRF Yahoo. Nothing, because it will take some time. You can say clear BGP VPN v4 unicast star on to R2. See, onto R2 they are available with the RD value 2:2. That is why there is no confusion now, right? However, it is having same prefixes. I must be able to see them onto R3 as well. What is happening? Sure, run pipe section, router, BGP. Let me show you actually. It have created VRF for Yahoo as well, then why is it not? I mean, it have created address family for VRF Yahoo as well. So that should be same. That's what we have to do. Over there we use that as export, and here I have to use that. I have to use them as import. Show IP VRF. Might be. Let's check it out. This is 3:4, and on P1 show IP VRF detail. For Yahoo, for export, it is same 3:4. There should not be any problem. See how came. Took some time, right? Received them. Even if you say show IP BGP VPN V for all, enter. This is for RD and this is for RD. Tell me, any problem? Sure, fine. It means that now I must be able to receive all these prefixes in VRF. See, one is for micro, same prefixes are there. See 10.1.1.0, 2.0, and in VRF Yahoo as well. See, it's not it, but here outgoing label for each VRF for the same prefix will be different, because PE1 have advertised that label towards PE2. See, show IP, check it out. Show IP BGP VPN V for VRF is what? Micro, and then say 10.1.0. Check it out. What is its outgoing label for VRF micro? Is 24. Whereas for VRF Yahoo for the same prefix, you understand? Its outgoing label is what?
27.
Because in this way, see, it created it. When it received it on FA0/0, then it created its label, local label as 24. When it received it on FA0/1, then it created label number 27. So of course for its neighbor, these labels will become outgoing label. Is not it? So finally R3 have received all these label all this information. And now let's do one thing. Let's configure EICRP in between PE2 and this Yahoo customer edge 2. So let's have the console of Yahoo customer edge 2 now. IP address is going to be now 4.1/24 itself. Create loop back 10.1.6.1. Loop back to 3, 4, 5. Any problem? Say. Fine. Move on. PE2. Router EICRP, we have to configure EICRP for VRF Yahoo AS 100, but globally you can take any AS, like I took one. Say address family IPv4 VRF, name is Init, define your autonomous system now. That must be same as your neighbor. Not a summary. Network. Go to F0Y1 IP VRF forwarding is what? Yahoo. IP address, it will be 4.2/24. Once you will say no shutdown, now your neighborship must come up. It have came up. So now ESGRP has been configured. As you can see here, show IP ESGRP VRF Yahoo neighbor. Check it out. 4.1 in VRF Yahoo. See, still there is no route available in its global routing table. Check it out. Show IP route VRF Yahoo. Some prefixes are coming with the help of ESGRP and some of them are coming with the help of BGP. So 123 is coming with the help of BGP. Apart from that, via ESGRP itself, because in between Yahoo CE2 and this PE2, it's ESGRP, right? But by default, prefixes can't move from BGP into, so say router address family IPv4 VRF is what, and then say redistribute BGP is what, metric is fine. Nothing over here. But if you move on, Yahoo CE2 now, you must be able to get all of them. But prefixes will not go from ESGRP into BGP. So on PE2 itself, router BGP address family IPv4 VRF is what? Yahoo. Redistribute. Fine. All of them must get redistributed into BGP now. So IP BGP VPN v4, or you can say VPN v4 VRF is what? Yeah. See. But you won't be able to get all these prefixes over there. Even if you move on R2, check for VPN v4 all. See over here, all these prefixes are there, but they are not going with any route target value right now. So no one will be able to receive them if prefixes are not going with the route target value. So we have exported them without any route target. Hello. So we cannot import them. Now we cannot import all these prefixes anywhere. We cannot. So for doing that, onto R2, onto our PE2 itself, say IPVRF name was, say route target for exporting is 4:3. Let's say 4:3 it is, right? And then move on PE1, and still you won't be able to receive them over here. Like show IP BGP VPN v4 VRF Yahoo. Check it out. Is it receiving them? And it will never be able to receive them. You know why? Because route target inside VRF Yahoo is not configured. See, there is no import route target. IPVRF, Yahoo say route target for importing 4:3. Now wait, we can say clear BGP VPN v4 unicast star in. Now wait for a moment. For some time prefixes will be appear over here. Check it out. Right? Understood? Show IP route VRF Yahoo. You must get them. And then after further you have to redistribute this BCP back into OSPF. Router OSPF, it was 100 VRF. Yahoo say redistribute. Then say right. Fine. Now you must be able to see all of them onto Yahoo CE1 now. Check it out. And now from here Yahoo CE1 you can try to communicate with 10.1.6.1. Source is loop back 1. Repeat. How can we confirm that when we are pinging from Yahoo CE1 we are pinging to Yahoo CE2 only, and if we are pinging from Microsoft CE1 we are pinging to Microsoft CE2 with using the same IP addresses? We can use telnet. Like what will I do? I will move on Microsoft CE2 and I'll say enable password Cisco line VTY02 for password is what? Cisco to show history. On Yahoo CE2 as well. Now move on Microsoft CE1 and say telnet and .1.6. When source is loop back. See what is this? And if you are moving on Yahoo CE1 now, and from Yahoo CE1 take telnet with using same IP address. And it is happening due to labels only, because there is VPN label, and how VPN label works in previous class I have already explained it.
सर वो बताना जब MPLS बैकबोन में जब प्रीफिक्स जा रहे हैं तो एक लेवल VRF के लिए लग रहा है सबसे पहले वो बॉटम वाला लेवल होगा,
and top level will be LDP level, which is for next hop. Because see, just check. See, whenever packet will be arrived onto FA0x0 of P1 coming from Microsoft CE1, it will receive it untagged inside VRF micro. And whenever a router receives untagged packet, it always perform lookup in its CEF table, CEF, and then you can move on PE1 and you can run this command: show IP CEF VRF micro for which 10.1.6.0, and then you can say (17) is LDP label, which is top label,
जो दे सकते advertise के
which is for next hop, like show MPLS forwarding table to reach next hop. Outgoing label is 17, and next hop is what? 333. So this is to reach next hop, and this is for identifying your VPN label 24. As you can see here, show IP BGP VPN v4 VRF micro for 10.1.6.0. check it out. Outgoing label is what? That is why here in SAF table it is what? So whenever this packet will arrive onto our R2S1/0, it will come with the label number, because outer label was 17. So now say show MPLS forwarding table. If anything comes with 17, it will remove it. It will remove 17. Will send it out from S1/1. Means it will be received now. It will be received by R3, and it will open the label, and which was 24. So whenever R3 will receive this packet coming with the label number 24, so it also received labeled packet, so it will perform lookup in its LFIB with the label number, see, 24. So it will send this packet out from FA0/0, and you will send, right? But if packet is arrived on F0/1 going towards Yahoo CE2 10.1 for the same prefix, right? So it will perform lookup in its SAF table for VRF Yahoo, show IP SAF VRF Yahoo 10.1.6.0, and then detail. Check it out. 17, which is next for next hop, right? And 30 is for destination. As you can see, show IP BGP VPN v4 VRF Yahoo, and then 10.1.6 for the same prefix, right? Its outgoing label is what? 30. So it will send it accordingly out from S1/0. R2 will receive it with label number 17. It will perform popping, and then finally R3 will receive this packet onto S1/0 with label number 30. So if R3 receive anything with label number 30, it will be forwarded out from F0/1 towards 4.1. So prefixes are same, but labels are different. So basically routers are forwarding your data based on labels. Understood? So I hope that now you people have understood all these things, and on R2 still we do not have any prefix available in its routing table, but still traffic can go from one branch to another branch of multiple customers through a single service provider with using same prefixes itself. Fine guys, so I hope that you people have understood that how traffic is going from one site to another site, right? This whole process. Now let's assume that these two customers are using different prefixes. See, done. and then I'll show you, or we will perform practical of like two different customers wants to communicate with each other. I mean, let's say that their network has merged now. You are performing some migration now. So how will it be possible for you guys to establish connectivity between two different customers, right? So we will be performing that. So now, first of all, let's move on Yahoo CE1 and see this time on to loop back one. In place of 10's network, I'll be using 20's network. OSPF is already enabled because I use 000 command, right? Then on Yahoo CE2 as well. Fine. Okay. Then now Yahoo CE2 must receive all prefixes coming from Yahoo CE1. See, all of them are coming, right? Hey, redistribution was already done. Everything was already configured. I just changed prefixes, right? So now in Yahoo CE1 also you can find 20 prefixes coming from different branch. Ping 20.1.6.1, source is loopback one. There will not be any problem. Even today, without specifying source also you can communicate, because we are also advertising their WAN prefixes. So there will not be any problem, right? After it, now my next task is here that I want that Gurgaon site of Microsoft must be able to communicate with the London site of Yahoo. And of course, the LAN users of customer Yahoo London site must be able to communicate with the LAN users of course, this Microsoft site Gurgaon. Right? I mean, their LAN users must be able to communicate with each other. So we know very well that R1 and R3, they have already exchanged their prefixes with each other. We are also having VRF available onto both devices, right? So see, R3, I mean PE2 is advertising prefixes of Microsoft CE2 into BGP VPN v4 address family with route target value with export RT 2:1, as you can see on PE2. Show IP VRF detail. So in VRF micro, we are using here export RTS 2:1. It means that PE2 is advertising prefixes with export RT 2:1. So they are coming, I mean, all those prefixes from Microsoft CE2 are coming onto PE1 with export RT 2:1, right? And we have imported them into VRF micro itself, right? We have imported them into VRF micro, but this time I wanna import them into VRF Yahoo as well, into VRF Yahoo as well. So for doing that, say show IP VRF Yahoo, or you can say detail. For VRF Yahoo, your import RT value is what? 4:3 only, but you can configure multiple import RT values in a single VRF. IP VRF is what? Yahoo. Route target for importing is 2:1 as well. So now show IP VRF detail. Check it out. For VRF Yahoo, now we are having
two different. So you will still keep on to receive prefixes coming from Yahoo's customer S2, but also you will start to receive prefixes coming from Microsoft CE 2 as well into this VRF now, because everything will be depending only on RT values. So now you see show IP, BGP, VPN, V4, VRF, Yahoo. So you must be able to see 10 prefixes as well. 6, 7, 8, 9, 10. See, all of them have came here. And then show IP route, VRF is what? Yahoo. Check it out. 10 prefixes. And now these 10 prefixes must be available onto Yahoo CE1. Move on Yahoo CE1 now. Check it out. And in same manner, PE1, this PE1 is injecting prefixes from VRF, Yahoo VRF into VPN with route target value 3:4. As you can see on PE1 itself, that show IP VRF detail. For Yahoo, your export RT is what? 3:4. So over there you have to import them with the 3:4. So move on R3 and then go to IP VRF is what? Micro. Say route target for importing is what? Show IP VRF detail. Check it out. Any problem? Move on Microsoft CE2 now and check it. 20s first 5 is not it. And now from Microsoft CE2 you can try to communicate with and logic is still same.
Sorry,
and traffic is going with labels. See what is happening. It will, Microsoft CE2 will send packet towards F0 by 0. It will receive, R3 will receive it onto F0 by 0, which is member of VRF micro. So it wants to reach 20.1.1 this time. So on R3 configure this command, because it received untagged packet, so it has to perform lookup in its fib. For that, so IP SAF VRF micro for 20.1.1. See 16 and 31, and this 31 is given from, hello, this 31 is given by P1. For P1 it is local label, as you can see. Move on P1 and say show MPLS forwarding table for 20.1.1. see, so procedure is still same. So in this way you can leak prefixes from one VRF into another VRF. Now there is a small problem now. The problem is like, if we are taking prefixes from VPN into VRF, all of them are coming. And if we are giving prefixes, if we are injecting prefixes from VRF into VPN, then all of them are going. If you want to filter some of the prefixes, then you can. For that purpose, here in VRF, we are having show IP VRF detail, import map and export map. You see, in VRF, inside VRF you can configure import map as well as export map. You understand? Hello?
Yeah.
Is there any problem now? Fine guys. See, this time show IP route VRF Yahoo. You are receiving all these prefixes. Forget about which are coming with the help of OSPF. I'm just talking about all those prefixes which are coming from VPN. VPN, I mean to say BCP, right? So all these prefixes are coming like 10.1.6.0, 7.0, 8.0, 9.0, 10.0, 20.1.6.0, 7.0, 8.0, 9.0, 10.0. Now I want to receive first 3 prefixes in range of 10, 6, 7, 8 and last 2 prefixes in range of 20, 8, 9. I want to receive only them. I want to receive only these prefixes. Except these prefixes, I want to filter out all of them. So I have to configure import map because we are importing all these prefixes from VPN into VRF. So we can configure import map. So what can we do? We can say access list 10 permit 10.1.0.0.0.3.245, then access list. Tell me 10 permit itself, then 20.1 sorry 8 or 910, right? Oh sorry, I created wrong ACL. Wait, access list 10 permit 10.1.6.0 7.0 8.0 then 20 9.0 and then 10.0, right? Create one, import permit, match IP address is what? ACL number 10. Then go to IPVRF, what? Yahoo, say import map, name is capital. Now say show IP, check it out, show IP VRF detail in Yahoo. Right guys, so it will import only those prefixes which are available in your import map. Check it out. 9 10, not 6 7 8. 6 7 8 is there but not 9 10 via BCP. In same manner you can also configure export map. In T-shoot they can inject problem with using this import map and export map, so that you will not be able to receive your prefix. So be aware with the import map and export map as well. Be aware with the route target values. They can misconfigure your route target values. Be aware with activate command in VPN v4 at assemblies, because if there is no activate command then it will never come up. Be aware with send community extended. If send community extended is not there inside BCPC, show run pipe section router BCP. As you know that if this send community extended command is not there, then it will not work. This one for its VPN v4 neighbor. So these commands are really mandatory. Have you understood it now completely, that how this MPLSVPN is working?
What are we talking?
Tell me. So basically in this way you can do all this type of configuration. Should I go for export map as well, or you can do it by yourself now? Because what? And usually what happens that there will be a separate VRF for internet at the end of service providers, and there will be a separate VRF for customer. So if customer also wants to access an internet, then ISP can leak prefixes from internet VRF into customer VRF. So that customer will start to access internet as well as it will be having, customer will be having inter branch connectivity, as well as customer will also start to access internet. along with inter-branch connectivity. See, even default route can also go through VPN, right? Like let's say that you are creating a like you are having a BGP, you understand? Not BGP actually. Let's say that this Yahoo London site is having a default route, you understand? So let's move on Yahoo, and let's create Yahoo C1 actually. So onto it say IP route 0000. Let's say it is connected with an ISP somewhere else, right? Any other, because let's say that this is only MPLS service provider, nothing else. It does not provide you internet connectivity. But this Yahoo CE1 is having an internet connection, right? I'll put that here over here. Now go to OSPF 1 and then say, what will you say? I think it was using 100. So say default information originate, and you can say always. And then you must find this default route available in the routing table of Microsoft CE2 as well as Yahoo CE2. So move on Microsoft CE2 now. Show IP route. You check it out. Wait. Oh, actually it will not get redistributed into BCP now here on 2R1, as you can see, like show IP BCP VPN V4 or enter. Check it out. For VRF Yahoo, is there any default route over here after redistribution? Of course it is not performing redistribution. However, show IP route VRF Yahoo. Inside VRF you are still receiving the default route, but you are not, it cannot be redistributed. Because by default OSPF will never redistribute external prefix into BGP. By default OSPF does not redistribute external prefixes into BGP. For doing that, like router BGP 100 address family IPv4 VRF name is Yahoo, as you said redistribute OSPF 100, and then after you said VRF is what? Yahoo. Then you said sorry, yes, Yahoo, and then you have to say match, internal match external, and it is coming as type 2. No, at the time of default route. See, now it is there, right? Oh sorry, it is not there. Default route is not there. Still default route is not there. Check it out for Yahoo only. Default route is there, but inside BGP it is still not there. 2:2. Is there any default route? No. What? Actually, in BGP also there is a rule that you cannot redistribute default route on any router until unless you configure default information originate command in BGP as well. Do you remember in BGP we covered that we were having two methods in BGP to create a default route. One, per neighbor default originate. It was generating a default route, right? Second, by redistribution, but before redistribution it was necessary to configure default information originate command globally, right? So here on PE1 router BGP 100 address family IPv4 VRF is what? Yahoo. Say see how many things are required. First of all, we configured OSPF, we forced OSPF to redistribute external prefixes as well into BGP. Then we forced this BGP to accept that default route, because by default in BGP you cannot redistribute default route, right? So now
Yahoo वाला route तो है नहीं है, BGP
Yahoo वाला ही है सर.
अब Yahoo वाला delete कर दो.
हाँ
Yahoo वाला जो default करा है
हाँ हाँ
उसको delete कर दो.
यार मैंने बताया था BGP में, क्यों भूल जाते हो? See, router OSPF 100. Check on P1 now. VRF. Does it have? Now let me move back again on Yahoo CE1. Router OSPF 100 say default information originate always. And then now you must get it on Yahoo CE2, right? You must be able to see that default route onto Yahoo CE2. So see, if internet connection, you bought one internet connection in branch London of Yahoo customer, right? But you can access internet in branch Paris as well from there, because with this default route you can go to Yahoo C1, I mean branch London, and then from over there you can perform netting and all. And because London site is already having reverse path towards you, so there will not be any problem, right? In same manner, Microsoft CE2 can also access internet. It's not it. It can also access this internet now. So many rules are there, small rules are there. So you have to be very careful. So in this way you can access an internet. Is it required for me to show you that okay, in this way you will configure netting now on Yahoo site London? Then I can take another router, I will use that router as an ISP, that I can configure netting onto Yahoo C1 and then we can access that internet. Is it required for me to perform that practical? We have already performed that actually, how to during CCNP we already performed all those practicals, like how to configure net and how to access internet and all these things. No? My god. Let's say this router is what? ISP. This is London side, and let's interconnect these two routers with FA0 by 1 to its FA. Oh sorry, there is no interface. F0 by 0, right? I'll be using some public IP addresses over here on Yahoo CE1. I mean, let's say that here it is configured. These are lane networks of Yahoo, right? Let's say that here it is 101.1.1 or .10, and at the end of ISP it is what? 101.1.1. Let's have the console of ISP. And let's say that it is having one loopback, which is and it is Google's IP address, right? Fine. You have to move on Yahoo C1 now. Onto its FA0 by 1, IP address will be 101.10. First of all, it cannot reach, like it does not have any default route over here. Does it have? So it is not possible to reach 111 from here, right? So it is mandatory to configure a default route in the direction of, right? And then you can ping with 111 from here. But you are pinging with using a global IP, I mean public IP, because it is going out from F0 by 1. Fine, it is going in this direction. Fine, but the problem is from Yahoo C1 itself. If you put in source your loopback, I mean your lane, your private network, see what is happening? Nothing. It won't be able to communicate. I mean, it won't be possible for it to communicate with it, right? So let's also do one thing. Say IP DNS server, IP host www. Say ping www. Right? And now, but if you put in source like your loopback, which is a lane, again you won't be able to communicate with it, right? For doing that, you have to configure netting now. I mean, let's configure PAT. So interface FA0 by 1 IP net outside, interface FA0 by 0 IP net inside. Then on to loopbacks also IP net inside and all. However, here you write loopback 2 and all these things, fine. Then say access list 1 commit any IP net inside source list 1 interface FA0 by 1, and then PAT is configured now. See, don't ask me anything related to PAT because you already done it. You already did it during CCNA and CCNP, right? So now ping www. IPNet translation. Then now let's assume that we want to communicate from Microsoft CE2. This is Microsoft CE2, right? First of all, say IP name server, which is DNS server, which is 20.1.1. Hello. IP name, IP domain lookup, and then ping source anything. Oh, on to Yahoo C1. It was also disabled. Yahoo Microsoft CE2. Let's try to communicate. I mean, what is happening? Type it out. Is it not reachable from here? 20.1.1. Oh, we configured over there import map. Don't you remember? So reverse path is not there. So on to R1, do one thing, do show history, IPVRF, it was Yahoo, and then no and then after you will see that all of them will be available in the VRF once again, right? Right guys, and show IP VRF detail, check it out. So now first of all let's do one thing, show IP on P1 itself, show IP route VRF is what? Yahoo. I must be able to see now all of them. See, all of them are there. So there should not be any problem now on Microsoft CE2. Internet. Even in source. Doesn't matter. From Yahoo CE2 as well. Ping. First of all, you have to say IP domain, lookup, and then IP name server, your DNS server IP address, which is Yahoo CE1 itself, right? So say 20.1.1, right? And then say www dot so everything is covered now.